So for example 2, it says first write as a single trig ratio. So that's telling you to think about your identities and see if you can recognize this as one of your identities, to write as a single trig ratio, and then evaluate. So in part A, do we have any identities that are cos squared minus sine squared? It's going to equal cos 2 theta. So for A, we're going to have cos 2. Our theta is pi over 4, so it'll be 2 times pi over 4. Does that reduce? Well, this is 2 over 1. If I simplify this, it'll be cos 2 pi over 4, which reduces to pi over 2. And cos of pi over 2 is equal to 0. Now, if this question said evaluate, and it didn't say first write as a single trig ratio, if it just said evaluate, you could have evaluated this one right from the beginning, because pi over 4 is on your pi plate. And cos of pi over 4 is root 2 over 2. So cos of pi over 4 squared will be root 2 over 2 squared, which would be 2 over 4. And this one would be 2 over 4 as well. And 2 over 4 minus 2 over 4 would get you 0 as well. And chances are, if this was on an exam and it said evaluate, you'd recognize that right away and solve it that way. Sometimes changing it just means it's a little bit less work. In this case, I think it's probably about the same. Now, for the second one, can we write that as a single trig function, as a single trig ratio? It doesn't quite match up, right? If we look at our formula, we have a tan 2 theta. It has a 2 tan theta on top, but on the bottom it says 1 minus tan squared. So if I'll just write out the formula here. Tan 2 alpha is equal to 2 tan alpha. Oops, that's a theta. 1 minus tan squared alpha. And ours has tan squared alpha minus 1. Now, we've seen questions like this before where something's not quite right, just in the wrong order. What did we do to get it in the right order? We factored out a negative. So if I factor a negative out of the bottom, that'll change my 1 to positive and my tan squared to negative. Some things about negatives and fractions. If you have a negative on the bottom of a fraction, that's the same as that fraction having a negative out front. It's also the same as that fraction having a negative on the top. In this case, I would think about putting that negative out in front of my fraction. Because then, if I just look at the fraction part without that negative, can you see that that does match up with our formula? So we can change this to negative tan of 2 times pi over 6. And 2 times pi over 6 is pi over 3. And tan of pi over 3 is root 3. I'm going to add a part C. Evaluate two sine of pi over 12 cos of pi over 12. In mathematics, we develop things to trigger things, right? Sometimes those triggers can be misleading. In this case, I designed this question specifically hoping that it would trigger, oh, it's a pi over 12 question, We did those this just today, right? Yeah. So you see pi over 12, you are going to be very tempted to trigger your pi over 12. And then you're going to have to do an alpha plus beta for the sine of pi over 12, another alpha plus beta for the cos of pi over 12. It's going to be this huge equation thing that you're going to work through. And if you did all of that work, I should probably make it an 8 to 10 mark question on a test. But this one was on an exam, and it was only worth 2 marks, sometimes only 1 mark. That means that there's a significantly shorter way of doing it than using your pi over 12. And again, this is where it's nice to have these formulas mostly memorized. So when you see 2 sine cos, you're like, that's the right side of my double angle formula for sine. So I can change this to be just because here's my thetas, and 2 sine theta cos theta is equal to sine 2 theta. That reduces to sine of pi over 6, which is just a half, which is a lot shorter than doing our double angle formulas twice. Four, 5, and 6 are ones that you can do for practice.